Yep, I think we're good to go. All right, welcome everyone, and thank you for joining the first SubRug webinar of 2026. SubRug is about sharing how we're using Revit to move substation designs forward and how Revit connected tools are here to shape the industry where it's headed. Most teams are still early in the Revit journey, but the momentum is starting to build. More organizations are moving forward with it, and some are already delivering real substation projects in Revit. The direction is clear. Revit is becoming the future of substation design, and the SubRug is here to help the industry move forward together. For those that don't know me, my name is Nelson Antunes from Eversource, and I will be co-hosting the upcoming meetings with my counterparts, Corey Burns from Olteg and Shabnam Pazuki from WSP. I'll let them introduce themselves. Corey, go ahead.
Hey everybody, and thanks so much, Nelson. Really appreciate y'all joining us. I think it's been a long time coming. So it's great to see that this is really making some progress. My name is Corey Burns. I work over at Olteg as the design technology manager. Been in the industry for, I guess I would say 6 years now. I was in vertical building design before that. So plenty of Revit experience and exposure, and I've worked pretty hard to try to get Revit as a real industry tool here in this industry as well. Very happy to be here.
Hi everyone, thanks for joining. I'm Shabnam Pazuki. I am a senior technical BIM manager at WSP and a Revit SME focused on substation design with over 13 years of experience in BIM, mostly Revit. My work is centered around improving BIM workflow, coordination, and efficiency across projects. I will be helping run these SubRug sessions, and I'm really looking forward to building a strong knowledge sharing community with all of you. And let's jump into today's session. Our presenter today is Clare Montgomery, CAD SME at the Scottish and Southern Electricity Network Transmission, with over 16 years of experience supporting digital design for electricity transmission projects. Clare will share how SSEN Transmission is using Revit, Civil 3D, and connected tools like ACC, and now Autodesk Forma, along with XR visualization technology to improve coordination and decision making. With that, let's turn it over to Clare. Thank you, everyone.
Thank you so much, Shabnam, and everyone. I'll just share my screen.
Sure.
Can you see this okay?
Yes, thank you.
Perfect. Okay, thanks so much for having us join SubRug today. I think this is an amazing opportunity to pull together on some of the challenges and the ambitions that we share, so very happy to join today. I'm going to give an overview of how we got started with Revit and with Autodesk Construction Cloud, or Forma as it's now known. I'll mention some of the challenges and the wins that we've had so far. And we're also joined by Michael Milligan, who leads our technical engineering team, and he'll follow up with some, after my slides, with some examples of how project teams are using our Revit model data. But first, I'll give a quick background about SSEN Transmission. So we own and operate and develop the high voltage electricity transmission system in the north of Scotland. Many years ago, our Highland grid was built as part of a national endeavour to deliver electricity to rural communities and utilise the local hydropower to feed the local network. But now we've got this new national endeavour to connect massive amounts of offshore and onshore wind energy and transform the Scottish Highlands into a renewable energy powerhouse for the UK. So we're upgrading the transmission system because it's critical for the delivery of both Scottish and UK net zero targets for 2030. And also we need to deliver that clean power and ensure we have energy security. So to meet this challenge, SSEN Transmission are investing over £20 billion over the next few years in mission-critical grid infrastructure, and this is one of the biggest investment programmes that the north of Scotland has ever seen. The projects also deliver a significant economic boost locally and nationally in the form of jobs, investment, housing. We do community benefit funding and other opportunities to deliver a legacy of the work that is being carried out. Looking further ahead, the National Energy System Operator has identified a series of beyond 2030 transmission projects to be delivered across the UK and including the north of Scotland. So we've got a lot to do. Back in 2020, I was one of only 3 CAD engineers supporting our engineering team at the time, and also supporting the environmental and planning teams to produce different site, route and layout options for transmission projects. So these options, we work on them internally to narrow them down and then take them forward for planning permission. So our internal CAD team, we work on these on the right hand side of this slide here. And then after that, we normally go to tender to have contractors develop the detailed design and construction drawings. An initial push came within our project engineering team to move away from working in 2D and embrace 3D modelling. That enabled us to introduce Revit and some other software tools. And we also recruited civil 3D design specialists into our team. 2D AutoCAD was the primary tool for electrical substation layout designs like the one shown, and some projects do still predominantly use 2D, but with all of our newer and current projects, we're working in 3D now. AutoCAD still has its place for single line schematic and detailed drawings with us just now, at least for the time being. When we first had a civil 3D designer join the team, he was able to use the tools to optimize this platform here. I'm hoping you can see my pointer to the top left here. In this case, the in-house model we used to verify what our external consultant's design showed and demonstrate that the design could actually be improved. From there, the civil model was created for this project here, and the cut and fill balance created gave an understanding of how much stone could actually be reused on site, and this saved on capital costs as well as a number of vehicles transporting stone to site, so reduced the carbon costs too. Oh, excuse me. I'll just move on to the next point. Oh, you can see at the bottom here as well, we took some of our civil 3D models into InfraWorks because that comes as part of the same AAC package. So we had InfraWorks, and it allowed us to create some very nice visualizations early on. As software packages out of the box, Civil 3D and InfraWorks have been great for us for substation projects because we could see the value of them very quickly. Revit is obviously a really powerful package that enables the creation of the data-rich 3D models. But out of the box, for quickly producing 3D buildings and floor plans, fantastic. But for substation electrical layouts, straight out of the box, as we say in Scotland, it's no use. So at this point, you can, if you want, scan this QR code and you'll see an example of one of our models created that I'm about to talk about. I'll keep the QR code on for the next part as well, so there's no rush. We dreamed big, and we planned to populate a library of custom parametric models and then start using that. And for months, we really struggled to get enough time and resource away from busy projects to develop this Revit library. So we decided to break it down and find a quick win. We kind of cheated. We pulled our AutoCAD blocks into Revit families and created this kind of hybrid library of plant models. They don't use all of the functionality of Revit, but they were key to allowing our CAD engineers to start to learn Revit, build up enough familiarity to produce the first full substation layout designs like you can see here. You'll notice our primary objective is to work through the design options and check the space requirements. So we don't include a high level of detail in our plant models. They are generic examples taking into account the worst case dimensions. So I'm going to move on from this slide just in case anybody wants a last chance to take that QR code. Okay, so the team members developed their experience using Revit, and they've gradually been building up the native families and adding that to our plant library. As well as that, we've got some safety clearance families created that allow a quick visual check of safety distances. And we also have things like indicative stranded conductors or jumpers. And for these, we use 2, 3, and 4 point families. We did look at conduits and other approaches for this, but the team landed on this approach because it allows us to snap to points on the plant items and bring that in quite quickly. Although we don't do detailed design, it is sometimes necessary to go a little further. So where space is tight and we want to check what's feasible. So this cable joint bay you can see here, created by Laura and our team, is probably the most complex cabling model we have in Revit at the moment. Generally, for site layouts where we show the underground cable, we would use the built-in conduits with the sizes and types and fittings there. And we include that as part of our basic Revit template that we make available to the CAD team, alongside our own view filters and underlays. And that ensures that they show correctly in our 2D plan views, so that they'll be much more straightforward for the team to use. So managing our content. All of our content from day one has been managed centrally by just simply using a dedicated project in ACC, or Autodesk Construction Cloud. So the team downloaded the desktop connector tool, which creates like a mirror folder on your desktop, very similar to OneDrive. And we ensure each team member has download permissions assigned in the ACC project. Some of them also have create permissions, and this enables us to have controlled updates to the library. When the family is created, hopefully this video shall play okay, we can save it to the ACC project just using the desktop connector, like a Windows folder on our machine. And the CAD engineer can then open that folder later on and simply drag and drop the family into the Revit model. So this makes it really quick and easy to work with. This year, we do plan to move the library to the content catalog tool, which is designed specifically for managing library content and comes with a plugin for Revit. But just now, the desktop connector approach is working well for us and was a nice quick win for us too. As we've been learning on the go, there's been a real team effort to enable us to build up our own collection of internal step-by-step guides and short video tutorials. So we store these in ACC Library as well, and it means that the team can access them and build up the skills as they need them. So here you can see, this is one of the first projects that we coordinated in the Construction Cloud. You can see that there's a 3D Revit substation layout and building model, but there's also a civil 3D model combined here too, and they're all combined in InfraWorks so that you can see the context in which it's set. As we grow our skills and our tool set, choosing the right software for each purpose has been and still is a learning curve. But as a general rule, we don't chase a single model. We try and respect the strengths of each tool. If it's a long, linear terrain-driven model that we need to do, we'll use Civil 3D, for example, underground cables, roads and platforms. If it's an overhead line route, our overhead line team use PLS CAD. If it's a short spatial coordinated and interface heavy space like a substation layout or a very short cable run, we use Revit. If it's about understanding the options or context, we use InfraWorks and so on. And this is a workflow diagram just showing how our substation design is developed. So you can see we have the electrical and civil layouts evolving together so that we can make better use of the cloud collaboration. They can be linked together using the model coordination tool. The civil 3D model can be used to extract, oh sorry, not the civil 3D model, the whole 3D model can be used to extract 2D views and information, and that can be used to update drawing sheets. That if there's any changes, they will update automatically. But we're trying to get away from this mindset of having PDFs emailed back and forth. We want to develop the 3D model and look to have the drawing outputs towards the end. When we manage our collaborative environment in the Construction Cloud, we split work into different areas so that we're able to control different access permissions depending on someone's role. So generally we work with a work in progress and a shared area in keeping with the BIM standards. In our work in progress area, we invite our engineers in so that they can help manage and see the evolution of the design, and they can also add in markups and sketches into the same space. And once we're quite happy with it, we'll run it through an approval process and take it into our shared space where we can invite other internal colleagues to view it, or we can bridge it to a project space where the contractors can get access to it as well. So as mentioned, we're using Autodesk Construction Cloud. And this is so that we're getting away from our transactional interactions from the project teams. So no more PDFs being emailed. We're using this online platform to share, review and track the design progress with all of the project engineers in our work in progress space. I'm going to, hopefully this video will play. There you can see they can access from either a list or from a map view. I've skipped a couple of steps here just so you don't have to go through our full folder structure, but you can see that they can access 3D views, different options without the need for an additional CAD viewing software. In there, they can also tag any issues or hazards that they spot, and they can be tracked using the issues tool within ACC. So that attaches that specifically to a model, and it can have an updated status along the way as it's developed. And this is a quick way of working and engaging people in roles across project management, document management, asset management. We get to a stage, especially when implementing BIM for our projects, that we recognise everyone has something to gain from having this one space we can all work. We're also actually able to access the models and the issues tool using MetaQuest 3 headsets, because we have Workshop XR more recently as well. So that allows us to have virtual walkarounds. The issues tool has been really useful for us recently, because we started to use it to track hazards, so that the information from these can be attached to the model or exported to a form or a spreadsheet if that's useful as well. So this collaborative approach, while we're using it for internal designs, it's also, if I click a couple of buttons here, being used for collaboration with contractors. So we can invite them into our space, and they can make the use of this collaborative space where we're all able to work. Access is controlled through different permissions within different folders. And there's huge potential in working together like this with industry experts as well. For example, our internal model library was a key enabler for us. Imagine what we could do if we were able to pull together to standardise and create a shared industry library. I'm also going to highlight here that coordinating some of this can get quite tricky. So we are looking to, in the future, incorporate the use of ArcGIS as a helpful single source of truth, so that we can get an overview of what's happening on site at different stages. I'll now quickly run through a couple of other tools we've used with our Revit models, in case these might be of interest for others to explore. So here you can see some nice visualizations, and these were created inside InfraWorks by Pavel and our team. And these can be great for public consultation or other presentations, and they're just a brilliant way to be able to coordinate what's happening. Within Revit, it also comes with a tool called Twinmotion. I'm going to play a demonstration here of this in a second, but if you go to your Revit model and you go to the view panel, you can see within Twinmotion, if you have that installed, you can start to see it actually takes your Revit model into Twinmotion, which is a gaming engine, and allows you to create some really nice animations, renders, and it's actually very quick. If anyone's ever used, for example, 3D Studio Max to do something like that in the past, this is so much quicker and faster. One drawback with Twinmotion is that it's not, I'll just let this play an example video. Oh, there we go. It's not geo-referenced correctly. So if you want the correct geolocation, InfraWorks is perhaps better. Within Twinmotion, when you're locating it, you are doing it by eye. So this is an example of one of our models brought into Twinmotion, and Laura has added some materials and things, and some of the context behind here is built in. So you can choose a background. It's not the actual location. It's built into the background. So she's chosen a mountainous background. That works well for us because a lot of our sites have got mountains in the background. And then closer to the site, you can show some terrain and maybe bring in some trees and other things as well. You can also bring in characters and vehicles and drive them and animate them, depending on how much time you've got to spend on it. And there's a lot of really good online tutorials for using Twinmotion, as well as on the Autodesk Learn website. So we found those really quite useful as well. Previously, we had found that where we had, for example, a point cloud of what was existing on site, we could take that into Revit and we could see that within our Revit model and maybe build onto that what was being proposed to add to an existing site. But when we took that and published it to the construction cloud, in the construction cloud viewer, you could view the Revit model, but you couldn't see the point cloud within the Revit model. So if the point cloud was published separately, yes, you could see that, but not inside the Revit model. So what we looked at doing previously was creating a mesh from the point cloud and keeping that within Revit, which you can see in the viewer. But our meshes using Recap 2024 weren't of high quality, and we had to keep purchasing additional tokens to create a better quality mesh. But with 2026, we found out that there's a new local mesh processing feature, so you don't actually need the additional tokens. So our summer placement last year was given the task of exploring this idea, and you can see how you managed to clip part of our point cloud and create a mesh of this transformer. And from there, he took it in to be a Revit family. And then from that, you can start to get the benefit of additional parameters and data. So it can start to become really useful. He did notice that some of the models, they're like a surface model and it doesn't look perfect in all situations, depending on the quality of the point cloud. So he did find some of these tools online as ways of repairing and improving how that looked. So there's an example here. He created this transformer and we brought it into our Revit model to complete the model. And then when it was published to ACC, it's not perfect, but you can see quite clearly it's there. And you can start to take measurements and things using the ACC viewer for that. So that was really useful for us. Put a little bit about file sizes there as well. Okay, how do we get more from our models? Obviously, we have started off, we don't have a lot of standard parameters and data, but the aim is that we want to standardize as much as we can with information so that we can align that, for example, with the tools that are used to track the asset information and maintenance and operational information, so that we start to tie everything together as one single source of truth. So we've been looking to standardize what we name things and work with different departments in our business to see what could work, and also start to reach out to other transmission operators in the UK to see if we can try and find a way to get a consistent standard, and potentially then see if we could start to work together on that dream of the industry library. If we have shared requirements, we could ask, hopefully in the future, manufacturers if they would be happy to share some models with us. As part of that, we would need to let them know how much detail we need. So with regards to intellectual property, when it comes to these models, we don't need to know the innards of what's happening, but we need a good visual representation with key points that we can take measurements for, depending on what stage the design's at. So we created this level of detail to help with the discussions around that. Something else I've recently been looking at is the data exchange tool. So within ACC, you can very quickly, from a 3D model, create a data exchange file. And then within Power BI, you can look for that data exchange file and it reads it the same way as it would read an Excel spreadsheet. So you're pulling all of the data from your model into a spreadsheet and you can combine that with other spreadsheets. So for example, in this one, I combined it with a very, very basic timeline so that different plants, different items of plant were shown at different dates. And then you can actually use a viewer tool and an animation tool and really start to play around with that. So this is something that we're starting to explore just now. I think that's got a lot of potential for other teams within the business to use. And I think I've come to the end of my slides now, and hopefully Michael Milligan is on the call and can cover some of what our project teams are doing. Are you there, Michael?
I am. Thank you for that, Claire. It's very impressive.
Will I stop sharing and hand over to you? Is that?
Yeah, do that. Yeah. I'll share my slides.
Okay.
So my name's Michael Milligan and I'm the head of technical project engineering in SSE. And that is sharing is not working, so I'll share my screen. Can you all see the screen?
Yes, we can see your slides, your presenter slides.
Oh, sorry, I tried to share from Teams into the meeting, but didn't quite work. So give me a second. Is that okay?
Yes.
Perfect.
Yes. Yeah.
Perfect. Thank you very much. So I'll start again. So my name's Michael Milligan, and I'm the Head of Technical Engineering within SSEN Transmission. And I manage a team of principal engineers, and we provide like technical design leadership within the project team. So focus on standard design and design quality, things like that. And I'm going to give you a little bit of an overview of how we use the Revit models and what the wider like benefits for us are having those data-rich kind of infrastructure models. So we start off with having, the civil 3D design, and we can overlay the substation Revit models with that. And, obviously, as Claire's shown, we can pull out, critical plant data in terms of like the performance of that plant, the electrical design requirements, even quantities, weights, materials. And that allows us to do things like automated cost analysis. So where we have things you're looking at with AI engines at the moment is taking our substation designs, dropping them onto GIS platforms and integrating with AI analytical tools where we can generate very quick cost estimates for our various options on the site. The benefits of using Revit is we can have that granular data in terms of component parts of what make up the substation. And it means that rather than getting to an end decision and going through a large exercise to estimate our chosen option, we can let costs play a bigger part in the decision-making process because there's not a lot of admin working in this way to look at the costings of various different technologies or locations. So that's one area where Revit kind of plays its part in supporting estimating our kind of project costs. We can also look at a very similar setup for generating like carbon assessments and impact on nature habitats, where data-rich Revit models placed in relevant locations, geographically relevant locations, clashed against nature and environmental data sets on GIS, we can have a really good understanding on our impact on habitats, watercourses, and also from the material properties, understand like SF6 gas emissions and also just the general embodied carbon on our sites. So that's another very good example of where switching to Revit and using those, taking advantage of the data within Revit can add a lot of future value. Some of this we are realizing, some of it we're just developing, but the only reason we can even think about doing this work is because of the groundwork that Claire and the CAD team have done over the past 3, 4, 5 years. And this is a video looking at how we can tie everything together. So this is a GIS map connected with exports from PLS CAD in Bentley Open Ground for ground investigation information, where we have our overhead line, we have our ground data, which we'll see in a second. So these are the structures from PLS CAD, the conductors from PLS CAD, the ground data boreholes from Bentley Open Ground, connecting 2 separate substation locations. We're about to zoom into the substation location. And this is a live work in progress Revit model and civil 3D model that's underneath this of a developing substation, and we can connect Revit through ACC onto GIS, which helps us stitch everything together. And for us, that is a really good solution for coordinating long linear assets. That's an ongoing issue in the industry. Like, how do you do that? Well, this is one solution that seems to work, and that's utilising the GeoBIM function of Esri GIS that came out maybe 3-4 years ago. So that's a really quick overview of how we use the output from our CAD team and our projects in the development phase. There's not all, that's the end of what I have. So yeah, just wanted to give a bit of an idea on how we can use this in practical sense in our projects. So can I hand it back to Claire or open for questions?
I can show one more slide if useful. I'm seeing we've actually got more time than I expected, so I'll just quickly show. I mentioned the content catalog tool, so I do have a little video of this working here. So with the content catalog, you can very quickly drag all of your libraries and components in and assign things like attributes as a way to filter and search through them, so that we found that quite useful, for example, to split things by voltage. We can also, if hopefully it shows on here, yeah, you can have different libraries for different things. You can control the versioning of these as well. And it links directly into ACC so that you can manage who can view the content. Nice 3D views there could be useful for people who aren't even working with the models, but they want to just see what we've got. Who can view it, who can update it, who can approve any updates to it. And you can see it opens within Revit there. So you can very quickly drag and drop what you need, and you can also see all the tags, so it makes it quite easy for us to filter. So that's something that we're going to be rolling out with our team quite soon. I've also got a little video of how we use Workshop XR. We've been, as I mentioned earlier, we've been using the issues tool within ACC as a way of identifying hazards and making sure that that information stays with the model as it goes through certain design stages. So this is a way that we can have multiple people together within the same model at the early design stage to identify and design out any hazards that we can. And we can invite people who are used to working on site, who are operational, who are used to doing the construction, to virtually walk around with the person who's pulling together the model and say, you know, look at something, and even if on paper it meets all of the clearances, they might be explaining to us why there's a better way to do that, or something could move because something's just not practical on site. So it helps everybody develop that better understanding, as well as obviously keeping all of the information within the ACC project. So previously, when we looked at virtual reality, we had used the motion for introverts and use the VR headset to connect into those. And yeah, you get a very, you know, pretty realistic view of the substation from that. But you have to have the model on device, and you have to have the device with permission to connect to the VR headsets. That can be quite difficult with IT rules. So this allows us to quickly jump into any of the models that we have in ACC. And one more thing I'm going to show, because I think my internet connection might be starting to play up. We have started to use, I don't know if anybody else is using this, the Autodesk Assistant. So where we have our library that I showed, and we've got all our little step-by-step guides, I add these to our specifications within the ACC project, and then we can go in and ask the Autodesk Assistant some questions, so that if we want to quickly find the process or the starting point or the specific guide on a particular thing that we're not doing too frequently, we maybe need a reminder or a prompt for, then it can show that up quite quickly for us. Beyond that, I've just mentioned that we are looking to work with the other transmission operators to see if we can get that content library one day. And I've mentioned Forma there. We've looked at it, some very early exploration of that. I think you saw more of that with Michael. But yep, that's just a summary slide of, I guess, hopefully everything that we've covered. And hopefully that timing is okay with Shabnam and Nelson. See if anybody's got any questions or anything they want to ask more about.
Great,
I think
thank
the timing
you,
is
Claire.
perfect.
And we have some questions Jacob asked, in the model you provided via QR code, is that model design considered 100% complete and ready for fabrication print of material to be made from?
No. So that model, all of the models that we produce internally, we're looking to be suitable for basic early estimations, yes, site optioneering, but they're not detailed design. So everything that we produce in-house at the moment is very early stage, just to get the space, the clearance and everything approved for planning permission and have enough information to do early estimates and to then have some information to hand over when we go out to tender and we have contractors come in and do the detailed design and construction. And hopefully in the near future, we will start to see some of those construction ready models being produced for some of our major projects. But it's only in the last year or so that our contractors have come on board with that. I don't know if you want to say any more on that, Michael. That's your end, your expertise, that part.
Great, thank you.
Even the more detailed models are not models that will currently go into fabrication. There are one or two contractors that have started developing detailed models that they will, take views of for the kind of manufacturing fabrication side, but it's not widespread.
Thank you. And another question is the component cost information maintained in a separate database that is updated and linked to the component in the Revit model?
Yes, essentially, yeah, to try and reduce the admin for the CAD users. We will keep the cost separate and link using a common asset code between a database of costs and your Revit components. So it's a simplified way of maintaining costs.
Great, thank you. Any more questions, everybody?
So if there's no more questions, Shabnam, I would say to the presenters, Claire and Michael. Thank you very much for the presentation. This is really what we're looking for in a lot of these subrugs is we're looking to see how Revit could basically move the utility space in a very connected environment where we can basically move more towards collaboration with other tools that are tied to Revit. So these discussions are going to be really important to continue spreading the message across utilities that we see a future in Revit, and this is really what we want to see. And I think if anyone has on the call has other people that are also interested, definitely as we do these subrugs, please spread the message around. I think it's going to be great to continue having these conversations. If there's any interesting presentations of other groups doing stuff in Revit, definitely feel free to reach out to me, Shabnam, Corey, or even SBS for hosting the meeting for us. Just let us know presentations, and we'd be glad to have those presentations in future subrug meetings or other discussions. So, Shabnam, do you have anything else to add?
No, just I want to say thank you all, and thank you to our presenter for sharing your knowledge with us. This session have been really valuable and insightful, I can say, and same as what you say, if anyone is interested in presenting in future sessions, we would love to have you. Please feel free to contact us. Thank you.
Thank you.
All right.
And we update the recording and put it in the chat box. Thank you.
And Shabnam, what I can do for this meeting is I can share my email address and contact information if you want to share yours as well, and maybe we'll
Sure,
do Corey's.
happy to do that.
All right. Thank you, everybody.
Thank you.
Thank you.
Thank you. Thanks.